DeepSeek's new upgraded model has already become world number 2 when it comes to the large language models across the board. In open source, it is enjoying the number 1 spot and has beaten the rest of the lot by a huge wide margin. We already have covered this model from various angles, plus we have already checked out its distilled version on the channel, as you can see on your screen. In this video, we are going to check out as how can we run the full DeepSeek-R1 model in quantized format locally, either on GPU or on CPU, but more realistically, CPU plus GPU. I'm going to use a library which I haven't used before. It is called as iklama.cpp for this purpose. iklama CPP is a high performance fork of the popular llama.cpp inference engine that's specifically optimized for running large language models efficiently on consumer hardware, particularly on CPU performance. This is Fahad Mirza and I welcome you to the channel. We have covered llama.cpp a lot on the channel. If you want to learn more about it, just search it and you should be able to find hundreds of videos around it. Now let's talk a bit more about this iklama.cpp. This project introduces advanced quantization techniques like the IQ3KR4 and IQ2KR4 formats that we are going to use one of them. This dramatically reduces memory requirements while maintaining model quality and features specialized support for multi-head latent attention or MLA architecture found in DeepSeek model. Let's get the ball rolling. We will start installing this iklama and then we will download the model and serve it on our local system. I am going to use this GPU card, which is NVIDIA H100 with 80 GB of VRAM, but the good thing is that you can also run it on 24 GB of VRAM and just try it out, and as per their GitHub repo this is quite possible, and we will also check out the VRAM consumption in real time. And I'm going to use this Ubuntu system. If you're also looking to rent a VM or GPU or CPU on very cheap prices, you can find the link to Massed Compute in video's description with a discount coupon code of 50% for a range of GPUs. Okay, so that is all done. Let's go and git clone the repo of this iklama.cpp. Shouldn't take too long. Next, we need to download the model. For that, we would need to install this Hugging Face Hub CLI. And this is the model which I'm going to use in a quantized format. That CLI is installed. Let's now log in to the Hugging Face, and then for that you would need a read token from Hugging Face, which is a free token that you can easily obtain from huggingface.co. Let me put in my token and then I should be logged in. Okay, that is cool. Now let me create a new directory. I don't think so I have created a directory which is called as checkpoints. Nope. So now I'm going to create a directory, and this is where I'm going to download this model. Now the model size is huge because if you know that the original model has around 671 billion parameters. So that is what we are trying to install on this system. I will shortly also show you the size of this quantized version, but I'm just going to start downloading this model. Okay, so the model is getting downloaded. There are quite a lot of shards at the moment. I'll just go up. So I'm just going to go with this one, and it's a massive model. Anyway, so you can see that the size of this model here. So let's wait for it to get downloaded and then we will go from there. Meanwhile, let me also introduce you to the sponsors of the video, who are Matrix. Matrix lets you create a realistic world simulator where you can run repeated simulations as A/B tests for your marketing captions, allowing marketers to test different angles and strategies. I will also drop their link in video's description, so please do check them out. While that downloads, going back to this model and this library, if you are not aware what this new DeepSeek-R1-0528 model is, there are two things which you need to do. First, go to my channel, search with this, and watch the second video. We have done a thorough testing on this just a couple of days ago. Secondly, bear with me, let me try to explain. So this is a state-of-the-art reasoning focused language model from DeepSeek that uses MLA architecture and mixture of expert design, making it particularly good at complex reasoning tasks while being more memory efficient than traditional transformer models. Because as you know that DeepSeek is from China, there has been some ban on some of the AI related hardware exports, and that is where DeepSeek is trying to eke out any sort of performance out of whatever existing infrastructure they have. And the R1 here indicates that it's part of the reasoning specialized model series, and 0528 refers to the May 28th release date. So that is what we are happening. And in more detail, what we are going to do in this video, we are setting up this optimized inference stack to run a heavily compressed model. So the total size is 666 GB, the original model, but this model has got two quantized versions, IQ3 and IQ2. We are going to use either one of them, and what it is doing, it has brought the total size from 666 to, I think this IQ3 is around 300 GB, whereas the other one has got 222 GB. So this is what we are going to do, but they are high, despite of the reduction in the size of the files. This is a high quality version of DeepSeek-R1, and that is what we are going to run. As I said earlier, this Q2 you can run it under 24 GB of VRAM, and IQ3 I believe you could run it on 48 GB of VRAM, but we will check out as how exactly it goes. Now the way this IK llama.cpp is doing it is that it is using advanced quantization and MLA optimization to achieve 32K context length in under 24 GB of VRAM while maintaining excellent performance, essentially getting enterprise grade AI reasoning capabilities as per their model card on this model if you compare it to the full precision model, but we will check it out. The model is still being downloaded, so should be good. You can see that the download speed at mass compute is quite good. Now, I have used the word MLA a lot during describing this repo and this model. MLA stands for multi-head latent attention. It is a memory efficient way for AI models to handle attention compared to traditional method. Let me explain it in more simple words. Think of it like in regular attention, in models, the model has to remember every single detail from your entire conversation history separately. With MLA, it compresses and shares information more cleverly, like having a smart summary system that keeps the important stuff but throws away redundant detail. Benefits are it uses less memory, it processes things faster because there is less data to shuffle around, and then it is really good at a long conversation. And that is what this ikllama.cpp is trying to leverage. Okay, enough talk. I will just now wait for this to get downloaded and then we will go from there. And both the quants are now downloaded. You can see that the total size is around 521 gig. Okay, so model is done. Next up, we need to build this ikllama.cpp. Unlike llama.cpp, it doesn't really come with pre-built releases, so we just have to build it first. And the CMake configuration is successful. And if you're wondering about this command, primarily this is building this ikllama.cpp. It is turning on the NVIDIA GPU acceleration with this DGGML CUDA on, and it is turning off the CPU math libraries because we are building it for GPU, for CUDA, of course, by specifying our compiler. So that is done. And now we can do the actual build by running this command. And it is building it. This is going to take a bit of a time, so let's wait for it. So it's been around 25 minutes and it is still building it. So you just have to be patient while it builds it. I think I have seen it taking around an hour or so, depending upon your system, for this to complete. Eventually it completed. It took around 40 minutes, but now we are good. You can also verify the version by just simply running this command. Okay, so you can see that now it is running this latest version, which is 3718. And now let me serve this model with the help of llama-server or iklama.cpp. So you can see that I am simply running this llama-server on my local system. I'm providing it the model path. First, I'm going to go with the IQ3 quant. And then by alias, we are just providing it a friendly name. Then we have this CTX size, which is a maximum context length. We are just going to go with the 32,000 tokens of conversation history. Cache type is CTK-Q8, and we are just using 8-bit quantized Q value cache to use to save VRAM. MLA is 3 here, as you can see, which is a multi-head latent attention level 3, and this is a DeepSeek's memory efficient attention. FA means that it is a flash attention for faster computation if it is available. Then AMB is 512, which is attention memory buffer size. Then F, mixture of expert, which primarily is enabling fused mixture of expert operation for faster processing. Then NGPU layer is 63. So I'm asking it that, okay, run 63 layers out of total layers on my GPU. You can increase it if you have more VRAM. I might try that out. And then override tensor EXP as a CPU, which primarily forces expert tensors to run on CPU. So this is primarily a hybrid GPU CPU setup. Parallel is one where we are giving it number of parallel inference sequences. I'm just going to go with single user. I'm not serving it in a multi-user environment. Then threads means the number of CPU thread for processing. And then we are binding it to my local host. And this is a default port which I'm going to use, port 8080. So as soon as you run it, it is going to start serving it. You can see that it is just loading all the layers, all the components, everything of the model. Takes a bit of a time. So you see all the stuff is being loaded and GPU CPU hybrid infra is being served. So let's wait. It took fair bit of time. As you can see that it has loaded all the layers and everything, but now it is serving the model on our local host at port 8080, which I mentioned earlier. Let's quickly check the VRAM consumption at this stage. So it is consuming just under 24 gig of VRAM, which they promised. So this is really cool. Let's now, I'm not sure if it, just like llama.cpp, it also serves the model here. I think it does, which is quite good. Can I access the new GUI? These are all the stuff which you can set. Okay, so I just want to go with the system prompt, which is always good. And this is a new interface of this llama.cpp. Even in this, I would just set the temperature to 0.6, which is recommended by the actual DeepSeek's upgraded version. And then let me ask it a reasoning question that, like, a farmer has 17 sheep, all but 9 die. How many sheep are left? Show your reasoning. So let's submit that. So it is running at the moment. Can I quickly check the VRAM consumption again just to make sure it is staying? Yep, because it is all the layers are loaded. And you know what? Because I have 80 GB of VRAM, so maybe instead of going with those 63 layers, I could just go up. Maybe I will try that later. It is running. What is happening in the other window where we have loaded it? So we see that it is loading and server is just telling us what exactly it is doing. Okay, so let's wait for this to come back. Now remember, this is running both on CPU and GPU, and considering it is just using that under 24 gig of VRAM, the whole big model in Q3 quantized level is now working to get the reasoning for us. I will just wait to see how long does it take, and then we will see. And after 10 minutes or so, it is giving me the output. I'm just making it a bit bigger so that we could read. Now, if you look at it, what we are trying to see here, that it is what sort of response it is producing when it comes to chain of thought. So It is, you can see that it is understanding the context, which is quite nice at what it needs to do. And it says the phrase all but can be tricky here. So I think the quality of the response is quite good. I don't see much difference between the full model and this. Yes, there will be performance degradation, maybe some hit to the overall quality, but still you can see that the response looks quite good. You see that it is also going into the language nuances, but it is very, very slow because it is all running on mostly on CPU instead of GPU. So what I'm going to do here, I'm just going to stop it and go back here. Also, I'm going to stop this server. I'm just going to, because I have 80 GB of VRAM, so what I want to do, I'm just going to make some optimization, and I will tell you what. It's the same command which I used earlier, but now in this one I am using full 16-bit cache instead of 8-bit, as you can see here, CTK. I'm keeping the context same. Then I am using the attention buffer from 512 MB to 2 GB with this AMB. I am also putting all the layers or whatever layers could be done with -1 onto the GPU, and it is saying parallel 4, so that is fine. 1, 4 doesn't matter, and rest is mainly I'm also using this SER61, which is a smart expert reduction. So let's see if it is able to do that. If it won't be able to do all the layers onto the GPU, it is going to give me the error. So let's see if it is able, if it loads it, we will run that again and see how that goes. Okay, so thankfully it has loaded everything on my system. Let's refresh this page, and I'm just going to go with whatever there is. Yep, everything looks good. This is a system prompt, and the funny thing is that it just gives llama, but don't worry about it. We can even remove this, but let's not worry about it. Let's give it the user prompt, the same one. I'm going to submit it. Let's check the VRAM consumption here in real time. So I think it is going to, you see, it has given us around just over 6 gig of VRAM. How is that possible? Anyway, let's wait. Maybe it is loading it. So I'm just going to wait and see what happens here. Okay, that is interesting. It is not going up. This is going to take more time. Maybe I will stop it, and then maybe I will reduce that parameter a bit. And now I am trying to force all the GPU layers on to the GPU. And I have also gone through their model card, and they have shared some secret recipe. It seems that the model is optimized for a RAM and CPU, and then some offload to the GPU. So even if I try to put everything on GPU, I think H100 is an overkill. You can simply run it on 24 GB of VRAM quite easily. Anyway, I will let this finish. This takes around 15 minutes to load anyway. So I'll wait, and then we will try again, and then we will go from there. And there you go, that errored out because it is unable to put everything on GPU. That is why it has just crashed, because of course the model is big, doesn't fit on my 80 GB of VRAM. So the only way is the hybrid mode for this model. Okay, so that was Q3. Let's go with quickly now Q2 by using the same hybrid model. And for the Q2, I'm just going to use the same original command, where I'm just putting in 63 layers to the GPU and pointing it to Q2. And I'm hoping that this should be relatively faster than the Q3, while still maintaining decent quality. Anyway, let's wait for it to get loaded. Okay, so the model is now again loaded. Let me go here. Okay, so I'll just keep everything as is. Let me go with some sort of a naughty one, where I'm asking it, I go to a coffee shop every morning at 8. The hot blonde barista always has my usual order ready before I ask. Yesterday I arrived at 8:15 a.m. and she seemed confused when I ordered, and instead of getting my order ready, she ran and hugged me. Today I came at 8 a.m. again, and she had my drink ready, acting like nothing happened yesterday. What can I reasonably conclude about what happened yesterday? So let's see how the model reasons about this. Okay, and let's check out the VRAM consumption in real time. So this time it has offloaded, I guess, 62 layers to my GPU, as I asked 63, and it is consuming over 16 gig of VRAM. So look, even if you reduce the number of GPU layers, then it should fit it on even your 16 GB of GPU, but of course the speed would be similarly slower. Anyway, so I'm just going to stop this because my system is already under a lot of load. I'll just minimize it, and I'm going to wait for it. There is a lot of wait in this video, and I understand that it has gone way over my standard video duration, but anyway, let's see how it goes. Okay, so it has started giving me the response, and if you look at the way it is printing the letters, if you compare it to the previous one, this is relatively faster. So let's check it out, what the quality of the response. So you see, it is understanding, it is saying this is an interesting situation. Let me analyze it step by step, because a lot of stuff is happening here. You arrive at 8 a.m. daily, and the barista knows your order well enough. Then yesterday, anomaly, well done. Arrived later, yes, 15 minutes later, so I just gave it a bit of a twist. He seemed confused and hugged you. Today everything returned to normal at 8 a.m. Reasonable conclusion. Time sensitivity hypothesis. So it has come up with this something hypothesis that the barista might have an internal timer based on your habitual timing. At exactly this time, someone else who looks similar to you or shares the same order, usually usually arrives. So you see, I don't think so that I sense any sort loss of quality here, to be honest. And look at this, twin or doppelganger or regular with identical habits. How good is that? When she saw you and you in double quotes arriving at that unusual time, confusion occurred. Emotional state theory. Perhaps something personal happened in her life yesterday morning. The hug might have been an emotional outburst directed toward the familiar face. How good is that? And then it is talking about what strongest evidence points towards the timing being key here. And then it is giving us the most logical conclusion. And I will let it run that what exactly it does. But I can tell you, look, that this is a real good stuff by these people. I think they are called some Uber Garm or something. Interesting. Okay, let's wait for it to finish writing. And it has finished its response. It has even given us a simpler take that she might have been sleep deprived, distracted yesterday morning, making her act out of character momentarily. Look, I think this is really fantastic. Really good stuff. We could nitpick as much as we could, but look, I think I'm very impressed by it. So that's it. Let me know what do you think about this model. I will drop the link to it in video's description. If you like the content, please like the video, share the video, and subscribe to the channel. If you're already subscribed, then thank you, and still please share it, as that's only marketing I do. Thanks for all the support.